In the vast, star-studded expanse of our cosmos, there are celestial objects that blur the lines between what we know. They are neither quite stars nor quite planets, but something mysteriously in between. These are the brown dwarfs, often called failed stars, and they are some of the most elusive objects in the universe. Why are these quiet giants so incredibly difficult for us to find? A brown dwarf begins its life just like a regular star, from a collapsing cloud of gas and dust. As this material clumps together, gravity causes the core to heat up and become incredibly dense. However, this is where the path diverges. For a true star to ignite, its core needs to reach a critical mass, about 80 times the mass of Jupiter, to start the process of nuclear fusion, turning hydrogen into helium and shining brightly for billions of years. Brown dwarfs never quite make it. They are more massive than the largest planets, but they fall short of the mass needed for sustained hydrogen fusion. They are the universe's almost stars. Because they don't have the internal engine of a star, they don't shine with the same brilliant, steady light. Instead, they glow faintly from the residual heat left over from their formation. This initial glow is primarily in the infrared spectrum, invisible to the human eye. As they age, they cool down and become even dimmer, fading into the background darkness of space. Imagine trying to find a warm, dark ember in a vast, dark forest at night, using only a thermal camera. That's the challenge astronomers face when searching for brown dwarfs. Their faintness means we need incredibly sensitive instruments to detect them. Telescopes like the James Webb Space Telescope, JWST, and the now-retired Spitzer Space Telescope were designed specifically to see the universe in infrared light, making them perfect for hunting these dim objects. A study published in the Astrophysical Journal highlighted this challenge. Researchers using data from a massive sky survey called Backyard Worlds, Planet 9 Inches, identified over 100 new cool brown dwarfs near our Sun. These discoveries were significant because many of these objects were exceptionally cold and faint, pushing the limits of our detection capabilities. They are like cosmic ghosts, drifting unseen through the galaxy. Another complicating factor is their size. While more massive than planets, they are typically about the same diameter as Jupiter. So you have a Jupiter-sized object that emits very little light, making it a tiny, faint needle in a colossal cosmic haystack. They are easily lost against the glare of brighter, more distant stars. Scientists classify brown dwarfs using letters. LT and YL dwarfs are the warmest and youngest. T dwarfs are cooler, and Y dwarfs are the coldest and most difficult to find of all. Some Y dwarfs are so cold that their surface temperatures are similar to a hot day on Earth, or even colder. Detecting such a minimal heat signature from light years away is a monumental technological feat. Finding these objects is crucial for understanding the full story of star formation. They represent the lower limit of what can be formed from a collapsing gas cloud. By studying their numbers and distribution, scientists can refine their models of how many stars of different sizes should exist in our galaxy. The number of brown dwarfs helps us understand the efficiency of the star-making process. Are they a common outcome or a rare anomaly? Current research suggests they are quite common, perhaps even outnumbering stars like our Sun, but we've only found a fraction of them. Their existence also blurs the definition of a planet. The most massive brown dwarfs can fuse a heavier type of hydrogen called deuterium, while the least massive ones cannot. This creates a fuzzy boundary between a giant gas planet and a small brown dwarf. As our technology improves, we are getting better at spotting these hidden giants. Future surveys and next-generation telescopes will peel back another layer of the universe's mysteries, revealing more of these failed stars. Each new discovery gives us another piece of the puzzle, helping us understand the dark and quiet corners of our own galactic neighborhood. They are a reminder that the cosmos is filled with wonders, many of which are still waiting silently in the dark to be found. We hope you enjoyed this journey into the dim world of brown dwarfs. For more deep dives into the cosmos, be sure to subscribe to Space Repo.